All right, starting number 6, you want to find the value of y in the diagram. Okay, well, this is an exterior angle, and we know that the exterior angles are equal to the sum of the non-adjacent interior angles. Okay, these two angles here are adjacent. Okay, this angle and these two angles are non-adjacent. Okay, so y is equal to 65 plus 36. So y is equal to 101. Done. Find the value of x in the diagram. Okay, we have an exterior angle here. It's equal to the sum of the two non-adjacent interior angles. Okay, once again, these two angles here are adjacent. This angle and these two angles are non-adjacent. Okay, so I'm going to have x is equal to 45 plus 41. X is equal to 86. Done. Given PQR, write the equation of a line which passes through Q and is perpendicular to PR. Perpendicular to PR. Okay, so here I have a line that passes through these 2 points. PR, right? All right, I need to figure out the slope of that line. Okay, so what I'm going to do, I'm just going to do this. I'm going to use some subscripts here. PR, just to indicate that this is the slope of line PR. So it's y1 minus y2, so negative 4 minus y2, 4. And then x1, negative 3, minus x2, which is negative 1. You could do it in a different order, put the 2's first and the 1 second. You'll still get the same result. So you get negative 8 over negative 3 plus 1. So I have negative 8 over negative 2, which is 4. All right, so my slope is 4. Now, if I want to figure out the slope of a line that passes through this line and it's perpendicular, what do you do then? The keyword is perpendicular. So I'm going to take this number, okay, which is 4 over 1 essentially, and I'm going to flip it. 1 over 4, and I make it negative. All right, so that's my new slope, all right, for the line that passes through Q. So I have y is equal to negative 1/4 x plus b, all right, because the equation of every line is y equals mx plus b. Okay, so the next thing I need to figure out is what is b? Well, I know this line is supposed to pass through this point here. All right, so that's my x and y. So I have negative 3 is equal to negative 1/4 times negative 8 plus b. All right, so I get negative 3 is equal to 2 plus b. Subtract 2, I have negative 5 is equal to b. All right, take the number and plug it in. So y is equal to negative 1/4 x minus 5. Done. All right, let me make sure we answered the question here. Write the equation of a line. Oh, yes, we did. We wrote the equation of a line. All right, that passes through that point and is perpendicular to PR. Next problem. Okay, given ABC, write the equation of a line passes through A and is perpendicular to BC. Okay, very similar to the previous problem, 63. All right, I need to find the slope of line BC. All right, so I use these 2 points. So I'm going to figure out the slope of BC. Using a little subscript here. All right, so I'm going to have y1, which is 2, minus y2, which is 9, over x1, which is negative 2, minus x2, which is 5. So I have negative 7 over negative 7, which is 1. Okay. Now I need to write the equation of the line which passes through A is perpendicular to BC. All right, excuse me, I had a little hiccup there. All right, so I have this slope. Write it as a fraction. All right, so they have to be perpendicular. All right, so what do I do to this fraction? I flip it, and I change the sign, negative. All right, so now I'm going to write the equation y equals negative 1x plus b. All right, how am I going to figure out b? That's where you use the point A, because it has to pass through point A. So that's my x, and that's my y. So I have 0 is equal to negative 1 times x, which is negative 6, plus b. All right, and I have 0 is equal to 6 plus b. I'll subtract 6, and b is equal to negative 6. Take that and plug it in. So I have y is equal to negative 1x minus 6. And if I polish it up, I have y is equal to negative x minus 6. Done. All right, in the diagram, ISO is isosceles. All right, and they tell you which sides are congruent. If x is equal to 52 and IO is 6, all right, the length of the sides, all right, the congruent sides is 6, find the values for the following. All right, this is 52 degrees. What is the measurement angle S? What is IS? Okay, IS, that's easy. That's 6, because those sides are congruent. And what's SOI? All right, well, I know that these angles across from the congruent sides, they are congruent. Okay, so I'm just going to give them another variable name. And I know that all three of these angles add up to 180. So I have 52 plus y equals 180. So I have 52 plus 2y equals 180. Subtract 52. I get 2y is equal to 128. Divide by 2, and y is equal to 64. All right, so measurement of angle S is 64 degrees, and measurement of SOI is 64 degrees. Alrighty. That's all there is to it. And here I have SOI. That's this angle here, just to be clear. All right, 66 in the diagram, ISO is isosceles. Okay, we have the sides labeled. If x is equal to 46, this is 46 degrees, and IS is 8. Okay, wait, that's 8 up here, so that makes the other congruent side 8. Find the values of the following. All right, IO is 8. That's really easy. All right, and to figure out S and IOS, all right, well, I know that these angles across from the congruent sides, they're congruent. So I'll call these y. And I know 46 plus y is equal to 180. So 46 plus 2y is equal to 180. Subtract 46. Now 134 is equal to 2y. Divide by 2, and y is equal to 67. All right, so each of these angles is 67. So that's 67 degrees, and IOS, that's 67 degrees. All right, that's all there is to it. Next problem. Write the equation of the line that contains negative 1, 7 and is parallel to the line y equals negative 2x minus 5. All right, parallel is the key word. Passes through this point. All right, equation of a line, y equals mx plus b. The lines are parallel, so I know they have the same slope. The slope of this line is negative 2. So I have y is equal to negative 2x plus b. All right, make sure you don't use this b. Okay, that's where this point comes in handy. That's how you figure out the b value that you're looking for. That's your x and y. So I have 7 is equal to negative 2 times negative 1 plus b. 7 is equal to 2 plus b. Subtract 2. And I have 5 is equal to b. Take it and plug it in. So y is equal to negative 2x plus 5. Done. All right, write the equation of the line that contains 8, 0, and is parallel to the line y equals 3/4 x plus 1. Okay, well, here's the equation of a line. I know these lines are supposed to be parallel, so they need to have the same slope. All right, so I have the first piece of information I need. Now I need to figure out the b. Make sure you don't use this b. Okay, that's where this point comes into play. This is my x, this is my y. So I have 0 is equal to 3/4 x, which is 8, plus b. So 4 goes into 8 twice. I get 0 is equal to 6 plus b. Subtract 6, and b is equal to negative 6. Take it and plug it in. Y is equal to 3/4 x minus 6. Done. All right, in the diagram, what is the exact distance between points P and Q? All right, so if I want to find the distance between 2 points, I have to use the distance formula. Alrighty, I have to figure out the coordinates. So I go back 1, up 2. Coordinates are going to be, all right, don't confuse obtaining the coordinates with slope. A lot of students do that. All right. So I have the x value is negative 1 and the y value is 2. And over here I have 1, 2, 1, 2. Okay, so I go right 2 and then I go down 2. Alright, there we go. So I have d is equal to x sub 1, which is negative 1, minus x sub 2, which is 2. Then I have y sub 1, which is 2, minus y sub 2, which is negative 2. So I have negative 3 squared, plus 2 minus negative 2, that's 2 plus 2, that's 4. So I have 9 plus 16, so the square root of 25, which is 5. That's the distance between the 2 points, 5 units. Alright, so if we look at this problem here, first thing I have to do is find the coordinates of each point. So I go back 4, and I go up 5. Alright, for B I go right 3, and I go down 2. Alright, so here's the distance formula. Alright, just be really careful plugging in your values. x1 is negative 4 minus x2, which is 3, plus y1, which is 5, minus y2, which is negative 2 squared. Alright, so I end up with negative 7 squared plus 7 squared. So that gives me 49 plus 49. Then I have 98. So here I have 2 times 49 and 7 times 7. Alright, so I end up with 7 square root of 2 as my distance. Done. Alright, 71. The coordinates of point D are 3, negative 6, and the coordinates of point E are negative 1, negative 2. What are the coordinates of the point that is halfway between these 2 points? Alright, halfway would mean we're trying to find the midpoint. So using the midpoint formula, alright, that's my x1, y1, x2, y2, x1, which is 3, plus x2, which is negative 1 over 2, y1, which is negative 6, plus y sub 2, which is negative 2. Alright, and I have 3 minus 1, which is 2, over 2. And I have negative 6 plus negative 2, so negative 6 minus 2, which is negative 8, over 2. So I end up with the midpoint, which is 1, negative 4. Done. All right, what is the midpoint of the segment connecting points -1, 1 and 3, 3? All right, so using the midpoint formula, and I don't really need the diagram in this problem. Or you could just recognize that that's your midpoint. All right, so you don't have to use the midpoint formula like we did in 71. Okay, so my midpoint is going to be, let's be careful calculating this, over 1 up 2. Done. All right, the midpoint of OP is the point M1, -3. If the coordinates of P are 6, 1, what are the coordinates of O? Okay, so here's the midpoint, 1, -3. Here's the midpoint formula structure. This is my x1, y1. So x1 is 6 plus x2, which I don't know, over 2. And then I have y1, which is 1, plus y2 over 2. Okay, now I set these x values equal to each other. So I have 1 is equal to 6 plus x sub 2 over 2. How do you get rid of the 2? We'll multiply by the denominator on both sides. Those cancel. I get 2 is equal to 6 plus x sub 2. Subtract 6. I get -4 is equal to x sub 2. I'm going to use that information in a moment. Then I have -3 is equal to 1 plus y sub 2 over 2. Okay, so then I have multiply by 2 on both sides. Those cancel out. I get -6 is equal to 1 plus y sub 2. Subtract 1, and I get y sub 2 is equal to -7. Alrighty. So my point O is -4, -7. Done. All right, the midpoint of KL is the point 35. All right, here's the midpoint. This is just like 73. If the coordinates of K are -3, -4, what are the coordinates of L? Okay, so I have to plug the values into the midpoint formula. I have -3 plus x sub 2. That's what I'm trying to figure out. And I have -4 plus y sub 2. That's what I'm trying to figure out. All right, so I have 3 is equal to -3 plus x sub 2 over 2. Alrighty, and multiply by 2 on both sides. Cancels out. I get 6 is equal to -3 plus x sub 2. Add 3. I get 9 is equal to x sub 2. Alrighty. Now I have 5. That's equal to -4 plus y sub 2 over 2. Alright, multiply by 2 on both sides. Cancels out. I get 10 is equal to -4 plus y sub 2. Add 4 to both sides. And get y sub 2 is equal to 14. So my solution is my point L. I figured out the x value, which is 9, and the y value, which is 14. Done. All right, provide the missing information in the following 2-column proofs. All right, they pretty much work it all out for you. That's nice of them. EA is congruent to CB. EA is congruent to CB. All right, that's given. And EAB is congruent to EAB. Is congruent to CBA. All right, that's given. All right, then they say reflexive property. All right, I have these two triangles here. Let me highlight them for you. I have the red triangle, and I have the green. Ooh, I have the green triangle. All right, and they share AB in common. So I'm going to say AB is congruent to AB. All right, that's the reflexive property. And now I know the triangles are congruent by what shortcut? SAS. SAS. Done. All right, in the diagram, what is the exact distance between points P and Q? Okay. I'm going to use the distance formula. Okay, I also have to figure out what these coordinates are. All right, so that's 4. I go up 3. And then I go right 4, down 3. Alrighty? So x1 is 4 minus x2, which is, oh, I did something wrong. That's negative. Watch out for those negatives. And that's negative 2. Son of a gun. Alright, missed both of those negatives. Okay, at least I caught myself. Alright, so that's negative 4. Negative 4 minus x2, which is 4. Plus y1, which is 3. Minus y2, which is negative 3. Okay. Alright, let's be careful with these negatives here. So I end up with negative 8 squared plus 6 squared. Okay. So I get 64 plus 36. I get square root of 100, which is 10. Done. Watch out for those negatives. All right, in the diagram, what is the exact distance between points A and B? Okay, so I need to use the distance formula. x1 minus x2 squared plus y1 minus y2 squared. All right, so go back 5 units and go up 4. I'm going to go to the right 3 units. I'm going to go down 4 units. I did the same thing as before. Missed the negatives. Here they are. Negative and negative. Watch out for the negatives. All right, so x1 is negative 5 minus x2, which is 3, plus y1, which is 4, minus y2, which is negative 4, squared. Okay, so I end up with, let's see what I have here. I have negative 8 squared plus 8 squared. So I get 64 plus 64, square root of 128. All right, we could simplify that to 2 times 64, 2 times 32, 2 times 16, 2 times 8, 2 times 4, and 2 times 2. I'm looking for pairs. All right, so I could pull out 3 2's, 2 times 2 times 2, square root of 2 left over, so I end up with 8 square root of 2 as my final answer. Done. All right, if one angle of a triangle has a measure greater than 90 degrees, then the triangle is called an blank triangle. All right, if one angle is greater than 90 degrees, that means it's an obtuse triangle. Done. Name the transformation that maps triangle ABC to CDE. Okay, what is a transformation? Well, we learned 3 different types. We learned translations, which in other words is shifting a figure. We learned reflections, and we learned about rotations. All right, so what's taking place here? All right, going from triangle ABC to CDE. All right, A went to C, and B went to D, and C went to E. All right, so every point shifted the same direction and the same distance. So that's simply a translation. Done. Name the transformation. Okay. Well, there's 3 different types of transformations. We have translations. We have reflections. And we have rotations. All right. What type of transformation took place here? Well, x goes to y. All right, x went to y, and a went to b, and y went to z. All right, so all the points shifted the same direction and the same distance. That would be a translation. Done.